Good afternoon, Professor. I am Yogita and my teammates Murli, Vamsi, and Sanjay. We are going to present about our project, an emotion-based music recommender chatbot. We built using a combination of advanced NLP and audio signals modeling. And our mission is to make music recommendations more human, more emotional, and more contextual. The next slide. The problem statement. Music isn't just entertainment, it's emotional therapy. But platforms today still rely on generic playlist or user curated tasks. What if our music app understood how we feel just from a message like I feel drained today? Our project bridges the gap between how we chat and the system emotionally aligns with the songs using machine learning. The next slide is about the innovations. The innovation here is twofold. First, we use BERT, a state of the art transformer model to extract emotional sentiment from raw user text. Second, we map those emotions to songs using engineered features like valence and energy from Spotify dataset. This is a multi-model recommendation engine grounded in the effective computing. The datasets we used, we combined two powerful datasets. Go Emotion from Google contains 58,000 Reddit comments with 27 emotions. It's ideal for training an emotional language model. On other hand, we have Spotify's dataset, which gives us metadata on nearly 1 million songs, including audio features, but no emotional labels. So we had to create those emotional labels ourselves using domain logic. Now, my friend Vamsi will be going to continue about the data cleaning and pre-processing.
Yeah, thanks, Yovita. And then this data, we have gone forward with data cleaning and pre-processing. So the first thing we removed was the noise from the data, and then we also normalized the slang which the daily use of people will use, like lit will be awesome, like that. And then we limitized and cleaned the stacks by removing the stop words. And then we also converted multi-label to a single mode label. And in the Spotify dataset, we have dropped the unused columns and removed the nulls from the dataset, and we added an extra column mode by doing some processing in the model. And we focused on 2010 to 2022 tracks for strong metadata. And next. So the feature selection is done in the Spotify thing. So what we have done is we have run our wrapper method, like recursive elimination method, to see which features are most eligible, most important to detect the balance. So energy, danceability, and acousticity were mainly important features which are used. So we use those datasets to classify the mood, the six modes we have done, and we engineered mood using threshold logic per song using these features. And the next will be grown emotion grouping strategy, and we have all over 27 emotions in the data set. We have gone for six moods, compromising them to happy, sad, angry, fearful, surprised, and neutral. Based on the mood classes to reduce model bias, we use thresholds on Spotify features to infer song moods. And then next, the modeling architecture gone by, we actually user gives an input of a sentence which he is feeling, and the text passes to the bird which actually we created to detect the emotion, the six modes from the user input, and then the emotion detected will be used to find the songs from the Spotify dataset, which we have originated from the original data set, and we recommend about 5 to 10 songs for the playlist to the user. And this end-to-end chatbot simulation will be very good to have mood uh, the songs which are mood collaborated with the person. And next, training setup and configuration. The but based on uncased checkpoint, we trained around six approaches which are using class weights around. So and then we used AMP for mixed precision acceleration, and then we fine-tuned 58,000 samples. And then what happened is, like we got a 57% accuracy in the in the emotion classifier. And then for the Spotify classifier, we have to split 8 by 20, and then we use random forest classifier and then wrapper methods to feature selection. And then by those, we made a mood label features as said before. And next slide, this is a text emotion classifier bud. So it shows fine-tuned bud based trained on that 133,000 samples, and then we found the accuracy 57% as said, and we mood-wise precision good for happy, angry, and lower for fearful, because the fearful has less samples of the data. From here, my friend Sanjay will continue.
Uh, Thank you, Vanshi. As we discussed, we have used two databases. One is emotion database and Spotify database. In this Spotify database, this is a rule-based but cleverly designed. We used engineered threshold on valence, energy, and a combination to label over 13,000 songs with their respective moods. For instance, low valence and high acquisition mapped to sad, while high danceability and valence mapped to happy. So we have clarified a group of formula to determine the mood in the Spotify dataset. And the next slide goes to evaluation matrix. Our bird model achieved an F1 score of 0.57 percentage and a F1 score of 0.61. The random forest model showed 79% accuracy on L out of data. While emotion is subjective, the model performed well under the practical constant with balanced class for distributing adding fairness. While visualizing this is the result which was shown by our project, the background image. Here you see the confusion matrix for the bird prediction and mood distribution of the song. Happy and neutral and dominant and expected. Some overlap exists between sad, fear, or joy. Surprise, but overall prediction reflect clear emotions. From here, then my friend Murli gonna continue this presentation.
Thank you, Sanjay. Coming to the challenges and limitations of our project. Basically, Bert can't detect the sarcasm and irony of the statement, which we have shown before. It has successfully detected the sarcasm here, but generally, Bert takes very hard time to detect whether sarcasm is there in the statement or not. So, in that kind of things, like. There will be a limitation for our model which can't predict the emotion of the statement. So yeah, and this is the other one. We can't clearly get the mood of the song. That is another limitation of the project. And the rest of two are depends on the person whether the user likes them or not. And the Go emotion dataset lacks like multi-label expression during the interface. And this is the future enhancements we plan to integrate our Spotify API and get more data from the Spotify app. We just have limited number of songs for some kind of emotions, like some particular emotions. So we the future plans of this project is like we can get Spotify API directly and we can get more songs. And we can also add speech to the model, which like we are just using text for now. We can add speech to it and we can like find the emotion from the speech and give song uh, related to it. Yeah, and the third one is like we can add personalized touch like that. And some coming to the summary, like contributions of our project is like uh, we built a hybrid system combining transformer-based text classification with music interface. Uh, we created like 943K songs manual, like the dataset has 943K plus songs manually using thresholds and fine-tuned bird classifier. And we designed an end-to-end chatbot that matches emotion to music, like they discussed in the starting part of this presentation. The We'll take the statement from a person or like a text from a person, and we'll get it through BERT, and we'll get an emotion from that, and we'll recommend a song from the Spotify dataset related to the emotion we got. So the impact and vision of this project is like there is lot of mental health support. by listening good music, we can support the patients, mental ill patients, like we can support them. And we also can be like can give music related to their mood, and we can, reduce the emotion they are in and make them feel happy. And the impact of this is the impact and the vision of our project is like basically with fine-tuning this project, we can increase the usage of AI into this, and we can uh, detect emotions even more better and give songs related to it even more better. So yeah, thank you. And now my friend Vamsi is gonna give a little bit demonstration of how the model has been worked.
The
Vamsi, can you
firstly,
share the screen?
yeah, I shared Murli. And then firstly, I want to show how we integrated a song data set. So first we have took the data set, and then we have actually feature selected the regular features which we got around the best features for danceability, energy, acousticness, which instrumental has less actually, and then balance. So we took these as to specify the song mood, and then we actually but classified and then started to implement the song dataset over here. So, for example, I told like I want to make love with my girl. It's set like detected mood happy, and we actually gave away 10 songs of happy from the playlist. So this is how we implemented it, and then next is like my friends happy because I am sad. This is actually sarcastic. So the mood was sad because the bird has actually detected the emotion of the person who typed it. So this is a success thing. And then we also use like words like lit up the fire. It says neutral, which is very common. So this is how we demonstrated the emotion based music chatbot. Thank you.